Yes. All right. It works. All right. 642, area of a sector. So we were starting off by just reviewing the area of a circle is just pi r squared. So if I have a circle with radius 5, I just plug it in for my r for the radius. It ends up being 25 pi because r squared is 5 squared is 25. Okay. So if I were to just say, what is the area of a circle? That's everything inside, right? Area is everything on the inside. I think I can see that. So since the area is everything on the inside, what would happen if I, let's say this is the diameter. If this whole area is 25 pi, what would happen if I cut it in half? The whole area is 25 pi, so what would this area be?
25 pi over 2.
Good. We would take 25 pi, we divide it in half. It would be 12.5 pi. Okay. So really what we know, this whole process is something we already know. We know we can find the area of the entire circle, and then the sector right here that I'm looking for is just part of the circle. And the way I figure that out is, deductively, I know that it's half because it's 180 degrees here. So if it's half of it, then I take whatever the area is, I just divide it into. Right? So this is going to be what we have to accomplish today. We need to find the area of this sector. So some of this, again, this is another one where it's kind of deductively how to figure this out without knowing anything else. If circle Z here has an area of 100, what is the area of the sector? You see this SECT? That's the area of the sector. Okay, so when you see that word, you know it's sector. You see area of a circle, which you'll see over here later. That's just the entire circle versus part of it. Okay, so somebody tell me what your thinking is to figure out what the area of this sector is. I know that the whole area, the whole circle is 100. So what do we got there? Wait.
Just divided by 4.
Very good. And how did you know that this is broken into 4 equal parts?
Because it's a 90-degree angle, and then and then 90 degrees of 4.
Perfect. Okay. So we were given a clue here. We knew it's 90 degrees. So this sector right here, I would just take the 100 and I'm going to divide it into 4 equal parts, and then I get 25 units. Squared. We've got to have the squared units. So the thinking with that is, we knew the area of the whole thing. We then take the whole area and we see what sector, how much of the entire circle we're having to look at for our sector here. So since it's 4 equal parts here, 90 degrees, this would be 90, 90, and 90. I'm looking at 1/4 of it, so I just divide it by 4. Okay. Just like yesterday, you're going to have 2 options. If you're given information in degrees or looking for degrees, here's your go-to. If you're in radians, here's your go-to. Okay. Some of these symbols are a little bit different, but it's nothing we haven't seen before. The question will always give you that info. Okay. So let's look at that. We have the area of the sector. So this little sector right here. It's going to be the entire area of the circle. And then look what this has here. Degrees over 360. Right? So if you think about that, what we just figured out, we had this kind of situation where we had the entire circle, and then we cut it in half. That's what we did over here, right? So if I cut a circle in half, what's the degree measure? The degree measure for half a circle, 180, right? So let's think about this. The area of the sector here, is half of the circle. It's 180 degrees. So it's going to be the area of the entire circle, right? So this entire circle, times some amount of degrees over 360. And this is going to be given to you, that degrees. So what we were saying is, we have 180 over 360. What does that give us? 180 over 360, what kind of fraction we end up with? 1/2. You see how this works? So the area of the whole circle, the whole thing, times 1/2 gives me the area of the sector that's half of the circle. Okay. So that's how we have to apply this idea. Now in this example here, we have circle in. It has a radius of 24. So radius of 24 units. So that's this radius. Find the area of the sector with the central angle of 30 degrees. So what I need to do here is take a peek at, I'm going to write the steps for this too. So let's say this is 30 degrees. So I took out my sector here, that's 30 degrees. I know that my radius, the radius is 24 units. So the first step for either of these kind of problems, the first step is to figure out if it's a radian or degree. First question you got to ask yourself, is it a radian or is it a degree, just like yesterday? Once you know it's this or that, then we're going to choose the correct formula. So looking at that, let's see if we can get it. There we go. All right. So looking at that, once you know if it's a radian or a degree, in this case it's a degree for sure, because we were given the degree value here, then you're going to use the correct formula. The sector formula. The last thing is going to be evaluate and solve. So if I look at this, I know we're dealing with degrees, so I'm going to use my area of the sector for degrees. I'm just going to write this out. Area of the sector is equal to the area of the whole circle, which we'll find right here. We'll do area of the circle times, what was our degree measure? 30 over 360. So again, we take the area of the whole circle, we multiply it by the portion of my whole 360 degrees all the way around. That's going to give us the area of that sector. So if I look at this, what's missing? I know I want to find this. I need to find the area of the circle first. So we're going to do that right here. Area is pi r squared. Pi times, what was my radius? 24. Let's go ahead and square that. 24 squared. 576. So I could say this is 576 pi. So the area of the circle is 576 pi, so I'm going to go put that here. 576 pi. All right. That's a number, that's a number, that's a number. All these are numbers on the right side, so now I can just carefully in my calculator multiply 576 times pi times 30, all of it divided by 360. Is that right? 150.8 units squared. We have to have it in units squared. I want you to write that at the top of the notes. Very top, units squared, box it out. Units have to be squared because it's area. It's the area of this little sector here. So basically what I did was I found the area of the sector by first finding the area of the circle. Did that here. And I plug in the area of the circle into the formula, and I also plugged in the central angle degree measure, which was 30. All these are numbers again, so I can find the area of the sector pretty quickly like that. So we followed our rules. Radian or degree is a degree. We use the correct formula based on degrees. We evaluate it and solve. That's what you got to do every time. All right, this next one actually I think is a little bit quicker. When we're dealing with degrees, and even finding the arc length, dealing with the circumference is an extra step. The same over here when we deal with degrees. We have to deal with the area of the circle, which is another step. Okay, but radians are really quick. Radians are always quicker. Let's look. Circle M has a radius of 8 units. Find the area of the sector with the central angle of 3 pi over 4. So 3 pi over 4 is our radian measure for our angle. I want to find the area of this sector over here that I took away. We know that the radius is 8 units. So first step, radian or degree problem. Has the word radians in it. It's definitely a radian problem. So I'm going to go ahead and use this appropriate formula because we're given the radians. So the area of the sector is, let's see, r squared, 8 squared, times the angle, which is in radians 3 pi over 4, over 2. So I'm going to just show you a way to simplify this that will help us. Is there anything that I could simplify in this to make it just a little bit easier? What could I simplify? The what over 2? The 2 here? And what else? 64 and 2 right here, right? I can deal with just this part. I want to deal with that first. This isn't 64 squared, that's a 2 over there. 64 divided by 2. I can get rid of the 2 in the denominator right here by dividing 64 by 2. And when I do that, I get 32 times 3 pi over 4. So that's my suggestion. You could have just multiplied everything, but I say let's reduce it or simplify it a little bit beforehand. Okay. Almost. Let's see. Now we're over here. All we have to do is calculate. Let's see. 32 times 3 times pi. Do all the everything in the numerator. Divided by 4. 75, 5.4. What kind of units? Square. Very good. Got it. Okay. I don't mind if for this you do focus on the formulas given for each of those type of problems. How do you feel about this one? Thumbs up, sideways, down for this? Okay. Okay. It's kind of in the middle. I think you do a couple problems. All the problems are really similar for this one. I think there's one that's kind of an oddball, so don't worry if you can't get that one. But it is on page 109, 1 through 8. Let's see if we can do number 1 or number 2 to start, okay? Before the end of the period, that is. Okay, don't forget to subscribe. I'm just talking to myself. Nobody subscribes. No, I have 108 now.
Nice.
Like Oreos? That doesn't do it. Maybe I need to give like a bonus point, and then everyone would sign up, not waiting for the end. Okay. So you get the point anyway if you already subscribed.